My name is Lakdawalla. I'm the senior editor of the Planetary Society, which is the world's largest space interest organization. We're a nonprofit organization with tens of thousands of members around the world, founded by Carl Sagan, Bruce Murray, and Lou Friedman in 1980. And I want to thank Megan Harberts for inviting me to speak to you guys today. My background is I am a planetary geologist. I studied planetary science at Brown University, but I finished there with a master's degree in order to go into science communication, which I think is why Megan invited me here today.
Yes, exactly. Sorry for the delay. I was just getting the last of the stragglers in here. So, did you already introduce yourself?
Yeah, I did. Actually. I'm good.
Okay.
I was a graduate student in planetary science, and when I first started attending scientific meetings about 15 years ago, I have to say it was a bewildering and dismaying experience. I would be in this vast dark room listening to talks with really amazing sounding titles about far off worlds, and I was completely confused. I had no idea what anybody was talking about, and I often was just sleepy. I would fall asleep because I would have no idea what anybody was saying in any of these presentations. Well, fast forward 15 years, and I go to scientific meetings, and I'm still feeling bewildered, dismayed, and sleepy a lot of the time, because a lot of these presentations, I was realizing, don't really do a very good job of telling me what it is that they actually want to say. We can make a bit of a game out of this. We can play bad presentation bingo. How many of you have seen this before? It's really fun. Last scientific meeting I attended, people were actually handing this out. It has such squares as text-heavy slides, no eye contact, excessive laser pointing, and so on. It's actually quite fun to play, and now on Twitter you can see people exchanging which ones that they've seen in different rooms at different conferences. While this is enjoyable, it's not very constructive. And so I got to start talking to my friends, the scientists, in the hallways outside of these meetings, that our hallway conversation was really fun and absolutely fascinating. Why wasn't that making it into the presentation rooms? And I realized that I actually, having had this background and experience in science communication, might have something to offer people to help give some tips and guidance on how you can improve your ability not to be boring and to actually communicate your science much better to your audience, whether that audience is your peers, whether it is members of the public, or whether it is people who you might be asking for grant money, which is also extremely important. All right, so let's approach how to prepare your talk in 5 different steps. Now, the first step that most everybody does is to start working on their PowerPoint presentation. And I have to tell you that this is absolutely the backwards, wrong way to go about preparing a talk. And I'll show you why it's backwards. Instead of talking about 5 steps to prepare your talk, I like to think about 5 questions that I ask myself as I approach preparing a talk. The very first and most important question is, who are you speaking to? Who is in the audience? Now, I think that today I am talking mostly to graduate students in the physics department, probably a few undergrads, maybe some staff, and hopefully 1 or 2 professors. Am I correct about that? More or less? Good. Okay, it's really important to know who is going to be in your audience, because different people come into the room with different backgrounds and different ability to understand what it is that you're talking about. Primarily, the way that this shows up and how you have to think about preparing your talk is when it comes to jargon. Scientific jargon is both wonderful and awful. It's wonderful because there are so many words that have very precise meanings, so that when you use them to communicate to people in your field, it provides a very efficient way to talk about your science. Unfortunately, for people who don't understand what that jargon is, it can be an impenetrable barrier to understanding your talk. I can give you an example. Consider a couple of words that I have to be very, very careful about my use of in my blog. Here's one of them illustrated, because anybody, you guys know that I am in a planetary science background. Here's another visual clue. Okay. I am talking about the limb and the terminator of a body that you will see in the night sky. The limb is the edge of the disk seen against the night sky. The terminator is the daylight boundary. But if I use those words when I write a blog entry about this picture, most people are going to be thinking about this and that. And it's not going to help my ability to communicate to the audience. You have to think very carefully about the words that you use when you communicate your science, and avoid jargon as much as possible. Another awful thing about science communication is acronyms. Acronyms are everywhere. I work with NASA a lot. NASA absolutely loves their acronyms. Most of the time they serve only to obfuscate rather than make things clear. People love to define an initialism in the beginning of a talk and then use it throughout the rest of the talk. And if you were spacing out for that first definition, you are stuck. And a good example in my field is RSLs. RSL is recurring slope lineae. And I can understand why they want to say RSL instead of lineae, because lineae is really hard to say. I would instead say these features that I'm going to show you in one picture slide at the beginning of my talk, and then I'll call them the features for the rest of the talk, because I defined it in the beginning, and I can use a word that people understand for the rest of the talk. So be very, very careful about your use of scientific jargon and acronyms. Jargon helps when you communicate with your peers, not so much when there are people in the room who may not know your particular tiny subfield. The last thing is context. Context is extremely important. You need to explain why it is that you are doing a particular study. Why should anybody care about your work? What this often means is that you have to spend a lot more time talking about setting up your talk, talking about why you did your talk, and talking about what your conclusions are than on your methods. I think people tend to focus a lot of their talk time talking about their methods because that's what you spent all of your time doing. But it's not actually what you need to communicate to people. What you need to communicate to people is the results of your work. All right, so to whom am I speaking? The second question is, what do you actually want them to learn? My favorite way of approaching this question is to compose a tweet summary of your talk, 140 characters long. That's all you get. You can't use text speak or Esperanto. It's got to be a complete sentence that explains what it is that you're planning to present in your talk. And then make sure that all the points in your talk speak to that summary. Don't let yourself wander down too many side paths. Focus on what it is that you're really trying to get across. Again, this has to do with you tend to speak mostly about your introduction and your conclusions. Spend less of your time on your methods. Leave your methods for the paper. Leave them for your abstract. If people are sufficiently interested in what it is that you presented to them at your scientific meeting, then they may approach you, or they may read your paper to find out exactly what your methods were and if they agreed with you or not. Now the next question that I ask is what is my story? What is the story that I am trying to tell? Story and narrative are extremely important in scientific presentations. They provide a roadmap for the audience. If you can tell your story in a way that the audience understands, using a framework that the audience understands, then even if they get lost in the middle of your talk, you can help them get back. There's a lot of stories that are really easy to use when you're communicating science. Often it's a detective story. We've got a mystery, we've got to pick up the clues, we've got to assemble them all together and find out who done it. And so if in the middle of the minutiae of picking up your clues, your audience loses you, you can bring them back to the end of the story by saying, okay, now all these clues pieced together, here's the tale, here's the story I'm trying to tell you. Another good one is exploring the unknown, going into uncharted territory. We went over the hill, and what was it that we discovered? One of my favorite stories is fighting a legendary monster of a data set. And this is really great framework to use if you have a null result. Okay, you did all this work, it didn't succeed, but you were a hero. You know, you were the hero of this tale, and you tried really hard, and well, here's what you managed to accomplish. And you may not have survived the trip, but you've got a great story to tell about it. Okay, so now the next question that I ask is, how long do I have to speak? And there's a reason that I put story before length in this one, because you can tell the same story in vastly different time scales. Many of you have probably seen favorite novels that have been turned either into one-hour shows or movies or serials that last for a really long time. They all tell the same story. They may have more or fewer characters, more or fewer subplots, but the same story is present in all of those. When you think about how much time you have to actually present, then you have to decide how many characters are you going to show, how many subplots, how many side paths are you going to go down. And it's crucially important not to run over your time. It is this is one of the worst sins that people commit in scientific meetings. Do not run over your time. If you run over your time into the question and answer section, that tells your audience that you don't care whether they understood your paper or have any questions about it. So it's disrespectful to your audience. If you run so far over your time that you run into the next person's time slot, that tells you that not only do you not care what your audience thinks, you think that you're more important than the next person in your time slot, and you're more important than anything else that everybody in the room was planning to do after you were speaking. And so that it comes off as extremely arrogant, not just ill-prepared, but arrogant to run over your time. Do not run over your time. It is better to be short than to run over your time. Now, you may be afraid, well, what if people don't have questions? What if I just stand up there like a loser at the end of my talk and nobody has anything to say to me? Well, prepare some backup slides maybe and say, because I have a couple of moments, then I can tell you about this and that I didn't get to in my talk. But don't run over your time because it looks really bad and it's very disrespectful to the audience and the people who follow you. Conference organizers hate you too. All right, now finally we get to the fifth question, which is what visuals will help me tell my story? We're finally at PowerPoint, okay? Most people start with PowerPoint. Here I'm telling you, you end at PowerPoint. After you've decided what story you're going to tell, what it's going to be in your presentation, now it's time to get to the visuals to tell your story. This, I think, is great news for procrastinators like me because it means you can still be making your PowerPoint presentation the very day before your talk. But you have hopefully been thinking about your presentation for a long time before you finally get around to making your PowerPoint. Okay, most people's problems with PowerPoint is that there are too many words on their slides. And they stand up here in the talk and they say the number one error that almost everyone makes with PowerPoint is there are too many words on your slides. We use the same parts of our brains to process spoken language and written language. You can see all of the terrible things that I'm doing while I'm reading this slide to you. I have my back to my audience. I'm doing the little Lawrence Welk bouncing ball on the words that make it actually very hard for you to even look at the word that I'm trying to point out. And because you're all trying to read this and listen to me at the same time, you have to choose one. You're either going to read this or you're going to listen to me. And odds are, because all of you have done a lot of reading all your life, you're much faster readers than you are listeners. You're going to be reading this. I might as well not be here. And so there's absolutely no point. The reason that people do this, well actually, there's a couple of reasons why people put too many words on their slides. I think one is that we've gotten into a strange habit of using slides as a record of a talk. This happens a lot in NASA. I don't know if it's as much in physics departments, but you find that people's PowerPoint presentations are, for some reason, supposed to stand alone without them even being present. And I ask you, what's the point of showing up physically to a meeting if it's not to connect with the audience, to present to an audience? You're not showing up to the meeting to read your slide deck to an audience. That's simply not the point of a face-to-face meeting. So I'd rather see people have slides that have notes attached to them that help explain what each slide was for. The other thing is that I think people use their slides as a crutch. They compose their entire talk in their slides. They're afraid that they'll stand up in front of the audience and forget whatever it was that they had to say. And so they turn around and they read their talk from their slides because that's a lot easier than coming prepared to present your whole talk to an audience. This is one reason why I like the story paradigm so much, because it helps you, even if you freeze and you with anxiety and you can't remember what it was you're going to say. You say, okay, let me get back to, what was that, Stefan? Oh yeah, okay, here I am. Take a deep breath and continue with your story. Okay, so what should be on the slides? If it's not your entire talk, what should be there? Well, titles help. Titles give little signposts to your audience about what it is that I'm talking at a particular point in time. I tend to space out, check Twitter, check Facebook while I'm sitting in the audience, and so I'll miss 30 seconds here and there. The titles really help as signposts for the audience. If you must use unfamiliar words or jargon, in planetary science, often there's things like place names can be very unfamiliar to people. Put those things on your slides, because if people don't hear them properly, they won't be able to search for them later. They won't understand what you're talking about. So those kinds of words can be very helpful on slides. Images, of course, are very important, but not necessarily in the way that they tend to get used. Here's an example slide talking about a kind of rock that the Opportunity rover saw on Mars shortly after it landed. And we have a title here, we've got a photo with a scale, we've got a bunch of lines drawn across it. Rather than showing the image this way, I suggest that you start with a fairly clean picture and build it up. So here is an example. This is a set of images that was taken by the Opportunity rover on the 41st day that was on Mars of a place that we called Upper Dells. Now we noticed in this picture that there is bedding that cuts through the rock, and you can see that the bedding planes are separated by just a few centimeters. But then at an angle to that bedding and truncated against the bedding is this cross stratification that we can see. And so this is an example of building up an image. Rather than presenting the audience with this entire mess at first, you first show them a single picture, and then you build up the elements of the visual story that you're trying to tell. This is something that it's much easier to do digitally than it was in the age of actual physical slides. When I was in graduate school, we were still using physical slides for our talks. And so building this up would have been impossible. Take advantage of the digital technology to be able to do this. However, it's not high tech. You can, in PowerPoint, do all kinds of fancy stuff with having things slide in, come in on a delay or whatever. These are actually, in my presentation, each one of these is a separate slide. And I do that because it'll work no matter what platform it gets converted to. Even if somebody changes this to a PDF before they present it, which does sometimes happen, and it's horrible when it happens, but you have to learn to deal with it. If every single one of them is a separate slide, your presentation will still work. Okay, so images can work, but you have to be careful with them. Graphs also, you have to be extremely careful about. Most graphs that are designed for publication are pretty lousy for presentation. So we have problems like the labels tend to be much too small on axes. The axes often are labeled in a rather arcane way that makes sense if you can read the figure caption, but it doesn't make sense when you don't have a figure caption on the screen. The other little symbols can be hard to discern. Yeah, here's another example of one that was scanned from a publication and then reprinted and I think scanned again. It can be very difficult to understand what these graphs mean. Here's one of my favorite graphs from a recent NASA press briefing. I call it the spinny principal components cube of death. It was actually, this is not the worst thing I have ever seen. The thing is that the person who is using this to make his presentation was trying to make a fairly simple point. His only point was that every time we shot our laser on the head of our Mars rover at a different rock, or I'm sorry, at a slightly different spot on the same rock, the composition was different. That was the only point he was trying to make with this graph. And he was showing that each point clustered in a slightly different place with a different color. Really, probably his point would have been better made without the graph at all. So think very carefully about how you use graphs in your presentations. Here's an example of a bad slide that I made a couple of years ago, where I was trying to ask people to compare 3 different graphs, but the scales are all slightly different. The lines are small. You have to look at the legend. And if there's anybody in this room who's colorblind, you probably don't understand some of the legend. I'm curious, does anybody in this room colorblind? Oh, wow. About 1 in 10 men tends to be colorblind, and that can cause some serious problems with interpretation of imagery. So you also have to be careful about that. So instead, what I'd recommend is you only show one graph at a time, only show one visual element at a time, and remove as much stuff from your graph as you possibly can. Make the labels large. Don't use a legend, because that makes people have to kind of go back and forth, and if the colors are slightly off, it can be very difficult. Try to label things as directly as possible. And again, build up your graph as you talk. So in this particular presentation, I was talking about what are the wavelengths of light that Voyager's wide-angle camera can see. What wavelengths of light do the different filters emit to the camera? And it has a violet filter, a blue filter, a green filter, and an orange filter that are used for building up red, green, blue color images that we see to see the beautiful colorful images of the planets and the moons. But these are slightly different from the way the human eye perceives color. So here's a part of the graph where that shows where the human eye perceives blue light, where the human eye perceives green light, and where the human eye perceives red light. And you can see that Voyager is quite deficient in the long red light wavelength. So Voyager images actually show a shorter wavelength. They're not quite true color pictures. And that's what I was trying to say with that set of 3 graphs that I had before. But if you were trying to run your eyes between all of those 3 graphs, it would have been very difficult to understand what it was that I was trying to talk about. So graphs can be used, but you have to be very careful about them. do not use graphs that you have prepared for publication directly in your PowerPoint presentations. Prepare graphs specially for PowerPoint presentations with as few visual elements as is needed to make the specific point that it is that you are trying to make with that graph. Same goes for equations. And I expect that you guys probably have a lot of equations in your presentations. And you're probably quite accustomed to looking at an equation and understanding how one term, an increase and decrease in one term can affect the balance of the equation and how things work. But again, you have to be extremely careful about equations. Don't just throw a massive equation up on the screen and expect people to instantly understand it. Equations are shorthand, and it takes a long time to look through and parse what it is that it means. Make sure that your use of equations is meaningful, and try not to put more than one of them on a single slide. If you do, make sure that you explain what the different terms mean and which ones are likely to dominate the behavior of whatever it is that you're talking about by using an equation. Do not put data tables on charts on PowerPoint presentations. There's absolutely no good reason to throw up a screen that is totally dense with numbers unless you're using the shapes of those numbers, whether there's a lot more of them over here than there are in this corner of the data table, unless it's a visual element, a visual point that you're trying to get across. We have lots of data over here, and we have no data over here. That's okay. But in general, data tables are quite bad in presentations. Okay, so there are points in your talk where no visuals will help make your point. Sometimes it's actually quite useful to have a totally blank slide because it makes a break at the point in your talk. It helps grab the audience's attention and make them understand that you're about to make a transition. I love putting blank slides at the point of a transition in a talk when I'm moving from one part of my presentation to the next step in my story. And it also gives you a chance to check in with the audience, see if people look like they're paying attention, asleep, confused, questioning. It helps you make that connection with the audience before you move on to the next part of your talk. Okay, so you've prepared your talk. You've got your PowerPoint. You're ready to go. Now, how to prepare to actually present it. The first and most important thing is to practice. Practice speaking your talk just for yourself in the mirror or in front of your computer. But I'm not just talking about practicing the specific talk that you're about to give. I'm talking about practicing speaking about your work in general. Whether that's talking to your friends over beers, or if it's trying to present your work to people at a cafe somewhere, going out in the public presenting your work, telling even your family about it. See if you can tell your family about your work without either boring them or confusing them to death. It's extremely useful. It's not, most of us have a fair amount of respect for our family members. It's not dumbing down your science to be able to present it to them. It's presenting it clearly. And if you cannot present your talk, your science clearly to people who are not in your field, then perhaps you don't understand it as well as you should. So practice speaking about your science, not just the specific talk, not just the specific work that you're presenting at a conference, but practice speaking about your science to diverse audiences. It'll help you. It also helps a lot to practice talking slower. I did a lot of work before I even started blogging for the radio. And the first and most important comment that I received from the producer of our Planetary radio show was to speak more slowly, because that way you will speak more clearly and enunciate your words more carefully. In science, it's crucially important to speak slower and enunciate clearly, because there are so many people in your audience who speak English as a second language. And it's greatly helpful to them to speak slow enough that they can parse your language and understand what you're talking about. It's also very helpful to split your sentences into many shorter ones. We have a habit in science, because we want everything to be precisely correct. We don't want to overgeneralize. We tend to pile subordinate clause and subordinate clause on the ends of our sentences, qualifying absolutely everything we say until you completely lose track of what the subject of the sentence was, and your comprehension absolutely falls apart. It works better to speak in shorter sentences. Finish one thought before you move to the next one. And that helps your audience understand what it is that you're talking about. Try giving your talk without your slides. This will happen to you sometime in your professional career. You will get up there to talk, you will have a 15-minute talk slot, 10 minutes to talk, 5 minutes for questions, and something's going to happen with the AV and it's not going to work. And you can either stand up there tapping your wrist and thinking, okay, what stuff am I going to throw away because I can't talk about it, or you can just get up there and start talking. You should be able to tell your story without having the help of your visual aids. Now, it can be hard, and you may be the principal investigator of a camera on a spacecraft, and it's really hard to tell a good story about those pictures without your images, but you can do it. You really can. And so, if you be prepared for that eventual day when you don't have your slides, and try giving your talk, try convincing the audience of what it is that you're trying to tell them without using your slides. Also, have a game plan if you find yourself running out of time, or conversely, if you find yourself having gone too short. It can help to have backup slides, but again, this is another place where story helps you a lot, because you can always expand upon a section of the story, or you can kind of collapse a bunch of stuff together and run to your conclusions. But don't speed up. If you find yourself running a little bit long, the worst thing to do is to start talking more rapidly, because that is simply going to confuse and lose your audience. They will learn a lot more even if you wind up saying less. All right, now, you of course have to dress to give a presentation. This is fraught for people who come from the kinds of backgrounds I do. I will tell you right now that it feels extremely strange to be giving anybody advice on how to dress, having been that person who in 4th grade made the error of wearing a turtleneck to my first day of school, and they didn't let me live that down through 7th grade when I left for a different school. So it can be very fraught for people. But you're not really trying to impress people. You're actually trying to kind of fly under the radar. You just want to look a little bit better than the average person in the audience. Just in terms of not in terms of how pretty you are, just in terms of the quality of your dress. So in geology, this is really not very hard. Most people come in jeans and t-shirts. A lot of the professors are wearing socks with sandals, okay? It's really not hard to dress nicer than the audience in that case. You can just go for the uniform, button-down shirt and pants. It's really hard to lose with that. Now I have seen in astronomy and other fields, or in Europe, as I use my water, people do tend to dress a little bit more fancily. And so you have to kind of look around at the audience and figure out, by going to several scientific meetings, what is going to look just one notch nicer than the audience in general. For men, it tends to be easy, button-down shirt and pants, bring a tie in your suitcase, and if people seem to be wearing ties, put on that tie. For women, it can be really hard. But again, you're not trying to impress people with how hot you are. You are simply trying to look tidy. Okay, just think tidy. There's a British word that I really like, which is smart. Okay, it doesn't mean the same thing in England as it does here. It means you look together, you look organized, okay? Just look smart. You don't have to worry about being super hot or fancy or whatever. And again, it's very hard for me to give advice about that. Something about hair though. For those of you who have long hair, men and women, a lot of the time we're using these lavalier mics. If you tend to wear your hair forward, don't do that when you're